Now that we have defined circle in the mathematical sense, now comes what are the key factors involved in a circle. Like every solid figure every figure which you have been discussing exclusively, like triangle, a parallelogram, or other objects which are discussed in the previous session, had their own basic understanding of the structures through the sides, angles, vertices, areas, etc. Similarly, a circle is also examined for similar kind of properties in understanding the structure of a circle. Key factors involved with the circle. Key factors involved in the circle. So what are the key factors involved in the circle? So let's take a circle and understand the key factors. More importantly, identifying the key factors in a circle. So here is the circle which is obtained through the pointer of the compass. So this pointer makes me understand that this is the center of the circle. So the fixed point from where the circle is derived is called center of the circle. So here comes center of the circle. So this point is called the center of the circle. Next comes the fixed distance. Now the second property we have identified in the mathematical definition is that this point is at equal distances from any point on the circle. So what is that equal distance called? The center is denoted by O or C, or generally I denote the center with C and my point on the end to be denoted by some P. So P is a point such that here the distance from center to one of the points of the circle is P. So what is CP called? Initially, the fixed point denoted by C is called center of circle. The fixed point C is called center of circle, and the distance from center to any point, that is the fixed distance, CP, is called radius of circle. So this is given by the special name called radius of the circle, as it defines the radius, the curvature. Therefore, the distance CP is called radius of the circle. So circle has two important key factors. One is the center, one is the radius. The fixed point being the center of circle and the fixed distance being radius of circle. Radius and center for the circle with fixed distance and derived circle is how we understand the key factors involved with a circle. Now that we have discussed about the center and the radius, now comes the question on how we can connect the center and radius, or how we can define the radius in different ways of understanding radius. So here the session is about understanding the radius. So radius, as we see, is the fixed distance from the center to any point on the circle. That is, when I take a circle, and when I take the center, this distance is called radius. CP, the distance CP is called radius, but sometimes radius is also represented by the line segment CP. So radius is generally denoted by small r. So when I represent the radius, I represent with r. Is how we define the radius. So radius denoted by r. And it's very important to note that radius is represented in both ways. Sometimes it is represented with line segment CP, which is r, and sometimes it is represented by length CP, which is r. So the two ways of representing radius, one is through the line segment CP, which is r, and one is through the length, which is mod CP, which is equal to r. But both mean the same, and radius is generally denoted by r. Is how we understand the radius connected with understanding the radius. And the most important understanding is, say for example, I take a circle, and a circle. So what is the difference I identified between each of the circles? How do we identify these three circles? Clearly, I see that the radius of each of the circles is different. How different? What is the relation between radius of this and this and this? So let me take the radius of the first circle is r1, the radius of the second circle is r2, and the radius of the third circle is r3. Then how do I connect the radius of r1, r2 and r3 is the biggest question out here. Clearly I can see that this is r1, which is smaller than r2. So I see here r1, which is smaller than the next radius, which is r2, and this is more smaller than r3. That is, the highest radius is this and the smallest radius is this. This is how it comes in ascending order. So the radius of the first circle r1 is less than radius of the second circle, which is r2, less than radius of the third circle, which is r3. Therefore, I clearly understand that as the value of the radius increases, as the length of the radius increases, the circle becomes bigger and bigger. So finally, we conclude that the radius of the circle decides the size of the circle. Very simple. The radius being small, the size of the circle is small. The radius of the circle being bigger, the size of the circle is also very big. Is how we understand the radius connected with the circle. Here I have a disk. The radius of this bigger circle is bigger, and the radius of this circle is smaller than the radius of the previous circle, and the radius of this circle is smaller than the radius of the outer circle. The radius of the smaller circle is the smallest, the radius of the bigger circle is the biggest. Is how we connect this with understanding the radius of three circles. So my learning outcome here is the radius of the circle decides the size of that circle. So here my learning outcome comes out to be that the radius of the circle decides the size of that circle. Smaller the radius, smaller the circle. Bigger the radius, bigger the circle. The size of a sun or the size of a earth, which are circular in shape, or the size of a moon, are decided by their radii, by the radius of the earth, the moon, the sun, etc. Radii is plural form of radius. That's how we connect the radius with the circle. Understanding the radius of the circle through its size.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.